A contaminant is anything that shouldn't be there. If it's not specified as part of the product, whether a material substance or energy, it's undesirable and adversely affects the product. Water in oil, grit in an engine, mud on the kitchen floor, or a fly in your soup are all contaminants. But we're going to focus on two groups of microcontaminants, solids and microorganisms. Air is a fluid, and in normal condition it flows, eddies and swirls to form invisible currents and turbulence that outdoors we call wind, and drafts inside buildings. Air is invisible until it picks up and holds solid dust particles that become visible when they reflect light, such as sunlight through windows or in the light beam of a projector. These airborne particles then settle onto surfaces and on or in the product. We're talking microcontamination, very small indeed. If it can be seen with the naked eye as dust in the air or on surfaces, then, comparatively speaking, it's a rock and relatively easy to catch and remove. Controlling microcontaminants is about solids that are measured in fractions of micrometers, commonly called microns, and usually shown as the symbol μm. 1 micron measures 1/1000th of a millimetre, that's 39 millionths of an inch. For many contamination-sensitive products, any particle above 0.5 microns is a contaminant, while for some of the most sensitive products, such as wafers for microprocessors, anything greater than 0.01 microns can be ruinous. To put this into perspective, with normal, unaided vision, we can only see particles bigger than about 50 microns. Smaller than that, and a microscope is necessary. To put that into perspective, the diameter of a human hair averages just 100 microns. Potential contamination is all about us. The next time you vacuum a rug, examine the contents of the cleaner. You may not recognize the source of all the contaminants, but you should get the picture. They may include cement or brick dust or plasterboard, paint chips, dried mud from your shoes, wood shavings, metal filings, plastics, dried food and beverages, or natural and synthetic fibres from clothing, furniture, and floor coverings. Solid particles can be held by and transported by processed gases or water and chemicals, not to mention those generated by tooling and the product itself. You, all of us, are great natural generators of microcontamination. When we talk, cough, or sneeze, we dispel fountains of saliva droplets that land on surfaces, dry into solid particles, and contaminate the product. And hair, we're covered with it, and it falls out, quite normally, from our heads, eyebrows, and eyelashes, from our hands, arms, and everywhere else, and from beards and moustaches, men more than women. But above all, we're the great contaminators because the human body is packaged in skin, several layers of it, each of which follows a cycle of decay and regeneration, usually over a period of days. The old skin dries and is discarded into the atmosphere as flakes. Not just a few flakes, but depending on the level of our activity and movement, by the million. While sitting still, we're casting off tens of thousands each minute, and the volume increases with activity, rising to literally millions during strenuous exercise. As they detach from our bodies, skin flakes are relatively large, with typical dimensions of 40 microns long by 10 microns across and some 2 microns thick. However, the action of our limbs and clothing rubbing together grinds them into much smaller particles. These submicron-sized particles are then dispersed into the atmosphere by the human microenvironment, a phenomenon created by the air in close proximity to our body, which has a normal temperature of 32 degrees Celsius, that's 89.6 degrees Fahrenheit. This warmed air then interacts with the ambient air at, say, 20 degrees Celsius, that's 68 degrees Fahrenheit, to form an upward air current. We can illustrate this by the use of Schlieren photography to show how this flow starts at the feet and accelerates up our body so that when it reaches the head, it's travelling some 60 centimetres, that's 24 inches per second. The finely ground skin particles are picked up by the air current that carries them up and out into the turbulent room air, and bingo, contamination is born. If you want further proof of how you shed your skin, take the covers off your bed and look closely at your mattress, because that white powder in the recess is ground up skin flakes, and if you examine it under a microscope, you may see that it's heaving with life. This brings us neatly to the next group of contaminants, microorganisms. Bacteria, viruses, and molds are microorganisms, and are described as viable because they are alive and can reproduce. They are extremely small, some so small that 1 million will fit on a pinhead. A handful of earth holds more than there are people on our planet. They are the most prolific living things on earth, and are all about us, many on us and many in us. When we're healthy, these benign organisms ensure that we function. But when we're ill, there are other malevolent varieties out to get us, that invade and overcome the goodies and cause disease and infection. They are all classed as hazardous contaminants during the manufacture of pharmaceutical drugs, medical devices, and biotechnology. They are also particles, and even though smaller than many other microcontaminants, they don't float about on their own, but attach themselves to larger inert particles, which someone once described graphically as riding to work on the trains and buses of our dead skin and hair, and they then form colonies. In addition, because they contain traces of chemicals, including sodium, calcium, and magnesium, they can severely damage many microelectronics components. Microorganisms breed very fast. Remember how quickly colds and flu develop. As single-cell organisms, bacteria reproduce by dividing themselves into two, and under the right circumstances of warmth and nourishment, they can do this every 20 minutes, which comes to tens of millions every few hours. So, whether or not your products must be protected from microorganisms as a health hazard or not, the speed with which they reproduce means that, in practice, they contaminate every cleanroom. For many years, airborne particles were considered to be the major source of contamination, as high as 80% of the total. But the increase in contamination-sensitive products and services and component miniaturization means that the sources of contamination and their delivery mechanisms vary in importance and impact from industry to industry. Contamination in purified water and other liquids and gases and in raw materials is relatively more significant now than in earlier years, as are contaminants generated by tooling and the product itself. Cross-contamination describes when equipment is improperly cleaned and chemical residues from one process remain in the system to contaminate the next, different process. A chemical cleaning agent can also cross-contaminate when it remains on or strays into an item of equipment and is improperly rinsed off. Cross-contamination also occurs when a person first touches one chemical, then touches an item of equipment, so leaving a residue. But of course, that's not limited to just chemical cross-contamination. You'll remember that the definition of a contaminant is any material or energy that should not be there. Most commonly, electrostatic discharge, or ESD, represents that energy source. Electrostatic charges exist when positive and